TRS clips, that one channel where you get to explore the unexplored realms of knowledge. Okay, now please correct me if I'm wrong.
Please.
There's a word called quantum physics.
Yes.
Now, what this basically means is that if you make yourself really tiny and you make yourself tinier than an atom, if you physically go in that world of the atoms, the laws of physics are not the same as they are in the real human world.
So the real human world, you're sort of saying what we would normally call the classical theory.
Yeah.
So everything you're seeing here is quantum. We're having a quantum conversation in a quantum.
What does the word quantum mean?
The first thing is I'm supposed to say nobody knows. So one of the great things when people say, I don't understand quantum physics, is that the physicists have to admit that neither do they. But, for example, if you probably have some cool polarized sunglasses.
Yeah.
And if you have two pairs of them and you turn them at right angles, no light gets through at all. That's a quantum effect.
Okay, hold on. Physics is the laws of the universe. If I drop this cup from...
What is possible?
Right.
Sorry. What is possible is determined by physics. What you can't break the law.
Sure. What does the word quantum mean?
The word quantum refers to a set of wave principles, laws about waves. Now, there are classical waves and there are quantum waves. And we call the classical waves fields for whatever reason.
What's an example of a classical wave?
So if, for example, you're at a stadium and somebody says, let's do the wave, and everybody gets up and sits down in a particular pattern, it will look like the people are moving around the stadium, but the people aren't moving except up and down. They're not going left to right. That's a wave. When you do the wave, you're literally behaving as a wave in a medium.
I'm going back to 8th grade physics.
Yeah.
Would you define a wave as a transfer of energy from one point to another?
No.
No.
No, I would define a wave as you have some medium, like a spaghetti noodle.
Yeah.
Or a bed sheet.
Yeah.
Yeah. And then you have something which is like an excitation, which is how much does it move up and down. And so in essence, quantum is a study of certain kinds of waves valued in the imaginary numbers.
What is valued in the imaginary?
It's like if I ask you a question, what is the temperature? You say, okay, it's 20 degrees Celsius. And then if I ask you a question about what is the pressure, you might say it's, 43 PSI. But I could ask you a question about what is the temperature and the pressure at the same time, and you could package the answer into a package of two numbers. So those two numbers can be made into what are called complex numbers, and a complex wave is a gadget with two pieces of information. So that depending upon where you are, maybe you get two numbers and they go up and down. Look, I'm trying not to lie to your audience.
No, that's fine.
It's a kind of mathematical gadget.
I'm trying to think of a metaphor to explain what you're trying to say for quantum waves. Like, how do we explain it using...
The photons. So right now, you and I are getting hit by photons that are falling on our faces, coming from your lighting system. And those photons have secret degrees of freedom. So for example, why do polarized sunglasses work? It's because there's an extra piece of information that your and my eyes can't detect called its polarization vector. But our sunglasses can detect it. And if the vector isn't lined up nicely, so think about your sunglasses as like a grid of straight lines. If the polarization vector is lined up properly, the photon can go right through. But if it's not lined up properly, it gets stopped. So that's how your polarized sunglasses work. It works on a quantum principle where you're taking an extra piece of hidden secret data that is in the light falling on the face, blocking some of it and letting some of the rest of it through.
Okay.
I don't really know how to explain this because no one does.
Okay.
Yeah.
That definition that I gave about becoming really tiny and going into the world of atoms,
Yeah.
that's not accurate?
Well, I can see what you're trying to say, but even macroscopic objects have quantum properties. So, for example, if your audience wants to blow their minds, they should look at quantum locking, where you see some sort of super cooled object that is levitating on a strip, and by the rules of quantum mechanics and quantum field theory, it stays bound to the strip, but it doesn't touch the strip. So you can have, quantum can allow you to walk through a wall. So a quantum macroscopic object can have various extraordinary properties. I just wanted to say that, yes, normally we found this stuff by looking at very small objects, but now we've gotten smarter about the quantum, and large objects can have quantum properties.
Thank you for consuming this clip, दोस्तों. अगर ऐसे ही और clips explore करने हैं तो इस channel के playlists को ज़रूर explore करना.